A rare visitor from deep space is racing through our solar system at unprecedented speed, and NASA's latest data has left scientists questioning everything they thought they knew about cosmic visitors. 3I Atlas, the third confirmed interstellar object ever detected, exhibits characteristics so unusual that some researchers are considering the unthinkable. Could this ancient wanderer be more than just a natural comet? As we uncover its secrets, the implications for humanity's understanding of our place in the universe become increasingly profound and, honestly, pretty terrifying. The breaking discovery. On July 1, 2025, the NASA-funded Atlas Asteroid Terrestrial Impact Last Alert System Survey Telescope in Rio Hurtado, Chile, first detected an unusual object later confirmed as 3I Atlas. This interstellar comet was initially spotted at a distance of over 4.5 astronomical units from the Sun, activating alarms across the global astronomical community. Its detection marked the third confirmed interstellar object ever observed passing through our solar system, following 1I Oumuamua in 2017 and 2I Borisov in 2019. The initial observations revealed a hyperbolic trajectory with an incredibly high orbital eccentricity of 6.141, the highest ever recorded for any known interstellar visitor. Larry Deneau from the University of Hawaii's Institute for Astronomy immediately recognized that this wasn't an ordinary solar system object, but a rare visitor that had been journeying through space for billions of years. The object's incoming velocity of 58 kilometers per second relative to the Sun marked it as the fastest interstellar object ever detected, surpassing both Oumuamua and Borisov by significant margins. From the outset, astronomers recognized that 3I Atlas was fundamentally different, initiating a worldwide mobilization of observatories dedicated to tracking this cosmic traveler and unraveling its profound mysteries. The discovery story. Between June 25 and June 29, 2025, the Atlas system had been gathering precursor observations that would later prove crucial in understanding 3I Atlas's trajectory and properties. These pre-discovery images, retrieved from survey archives and including work by the Zwicky Transient Facility at Palomar Observatory in California, helped confirm the object's interstellar path. Sam Dean, an amateur astronomer, contributed critical early tracking data, noting that the comet's trajectory through dense star fields near Sagittarius made early detection extremely difficult. The object's path passed through crowded cosmic neighborhoods, where countless background stars created a celestial camouflage, explaining why it had escaped discovery earlier despite being in the inner solar system for weeks. John Tonry, principal investigator of the Atlas project, immediately coordinated with facilities across the globe to confirm the object's characteristics once it was detected. The challenge of identifying 3I Atlas stemmed from its approach through regions where most sky surveys don't venture due to the overwhelming stellar background. This cosmic game of hide-and-seek had been ongoing since June 14, 2025, when the earliest pre-discovery images show the object silently crossing space. The rapid coordination between professional and amateur astronomers from multiple continents underscores the unprecedented global effort invested in monitoring this mysterious visitor. A stranger in our midst. 3I Atlas exhibits characteristics so unusual they continue to baffle the scientific community and challenge our understanding of natural cosmic objects. Traveling at a staggering 61 kilometers per second relative to the Sun, it far exceeds the speeds of its predecessors like Oumuamua and Borisov, making it the fastest interstellar visitor ever recorded. Its brightness is particularly notable, with a distinct coma and tail forming as solar radiation heats its surface, causing ice sublimation that creates spectacular visual displays. David Jewett from the University of California, Los Angeles, noted that the comet's tail and dust emissions provide rare data about materials formed in distant star systems billions of years ago. Perhaps most puzzling is that its trajectory lies almost perfectly within the ecliptic plane, the flat disk where most planets orbit the Sun, an alignment with merely a 0.2% probability of occurring by random chance. This mathematical precision has prompted serious speculation about whether the object's path represents natural celestial mechanics or something far more intentional. The combination of unprecedented speed, unusual brightness, and statistically improbable orbital characteristics raises fundamental questions about whether 3I Atlas is truly a natural object, or represents something far more enigmatic that challenges our basic assumptions about interstellar visitors. the predecessors. So, to really understand the true significance of 3I Atlas, we have to take a look back at the two remarkable interstellar visitors that came before it, each bringing their own, well, unsolved mysteries. The first, 1I Oumuamua, was discovered in October 2017 by astronomer Robert Warwick at the University of Hawaii. It immediately stunned the scientific community with its elongated cigar-like shape and honestly, its completely unexplained acceleration away from the sun, all without any visible signs of outgassing. This mysterious acceleration just defied conventional physics and sparked some pretty intense debate about whether the object could be natural or possibly artificial. Then, in August 2019, amateur astronomer Gennady Borisov discovered 2I Borisov from his observatory in Crimea. This one proved to be a more traditional active comet, showing the typical outgassing behavior you'd expect from solar system visitors. The stark differences between these two ancient travelers, one mysterious and possibly artificial, the other conventionally comet-like, have really intrigued astronomers worldwide and, more importantly, set important baselines for comparison. Mark Norris from the University of Central Lancashire has pointed out that 3I Atlas, being the largest and brightest interstellar object yet discovered, gives us unprecedented opportunities to compare and contrast with its predecessors. This growing catalog of interstellar visitors is finally starting to reveal patterns that could unlock secrets about the diversity, origin, and true nature of these cosmic wanderers from distant star systems. The cosmic journey. 3. I-Atlas's trajectory through our solar system, honestly, follows a carefully orchestrated path that gives us optimal opportunities for comprehensive planetary observation. The object will reach perihelion on October 29, 2025, getting close to the Sun at about 1.36 astronomical units, positioned just perfectly between the orbits of Earth and Mars for extended observation. At perihelion, it'll hit maximum speeds of nearly 68 kilometers per second, which really shows off the extreme velocities you get with interstellar travelers. Paul Chodas from NASA's Center for Near-Earth Object Studies has calculated that while the comet poses no threat to Earth, keeping a safe distance of at least 1.8 astronomical units, its path brings it remarkably close to Mars, Venus and Jupiter during its trip through the solar system. The precision of this trajectory is pretty striking. It allows close approaches to 3 major planets and provides optimal vantage points for studying inner solar system dynamics. Karen Meach from the University of Hawaii emphasizes that this close approach sequence is, honestly, an unprecedented opportunity to see how an interstellar object interacts with different solar environments and planetary gravitational fields. The object will pass just 0.19 astronomical units from Mars on October 3rd, followed by a 0.65 AU approach to Venus on November 3rd, creating a sort of reconnaissance pattern that seems almost deliberately designed for a comprehensive solar system survey, rather than just a random cosmic passage. A scientific goldmine. 3I Atlas, really represents an unprecedented scientific treasure trove for astronomers and planetary scientists who are studying materials from beyond our solar system. With an estimated diameter somewhere between 0.32 and 5.6 kilometers, it's significantly larger than previous interstellar visitors. That means it actually allows for detailed study of its composition, structure, and evolutionary changes as it interacts with solar radiation. The Hubble Space Telescope, operated by teams led by David Jewett at UCLA, has been tracking dust emissions and nuclear activity, revealing ongoing sublimation of ancient ices and continuous dust release from the object's surface. These observations are providing crucial insights into the comet's volatile content and primordial materials, likely preserved for over 7 billion years, predating our entire solar system's formation. Stephanie Malam from NASA Goddard Space Flight Center is coordinating advanced spectroscopic observations using the James Webb Space Telescope to, hopefully, identify complex organic molecules and unusual isotopic signatures that could reveal the object's stellar birthplace. Current analysis has already confirmed the presence of water ice, both as solid grains and vapor, along with hydroxide ions, suggesting a water-rich composition that's typical of objects formed in the outer regions of planetary systems. The ongoing research aims to characterize the complete molecular makeup, including potential carbon monoxide, methane, and complex organic compounds, offering rare glimpses into the chemical building blocks and formation processes of distant star systems. Unanswered questions. Despite intensive global observation campaigns, 3I/Atlas continues to harbor profound mysteries that challenge our fundamental understanding of interstellar objects and their origins. The object's precise nuclear size remains frustratingly uncertain because the surrounding active coma obscures direct measurements of the solid nucleus, which complicates crucial density and mass calculations needed to determine its true composition and internal structure. While spectroscopic analysis has confirmed the presence of water ice and organic compounds, the detection of other expected volatiles like carbon dioxide and carbon monoxide remains elusive, raising questions about the object's formation environment and preservation mechanisms during its multi-billion-year journey through space. Julia de Leon from Spain's Instituto de Astrofísica de Canarias emphasizes that the object's unusual thermal properties and outgassing patterns don't conform to standard cometary models, suggesting either exotic compositions or structural characteristics not found in typical solar system objects. Perhaps most puzzling is the object's remarkable preservation state. How materials billions of years older than our solar system could remain so well preserved and chemically active after eons of exposure to cosmic radiation and interstellar conditions. Some researchers are beginning to debate whether the object represents a completely natural phenomenon or exhibits features that might indicate artificial construction or enhancement, a possibility that would fundamentally challenge our understanding of what's possible in the cosmos. The alien question. The possibility that 3I Atlas represents humanity's first encounter with extraterrestrial technology has, sparked some pretty intense scientific debate and forced researchers to confront some uncomfortable questions about the object's true nature. Avi Loeb, who's Harvard's Frank B. Baird Jr. Professor of Science, has really emerged as the most prominent advocate for seriously investigating artificial origins. He cites the object's statistically improbable trajectory, its unprecedented velocity, and honestly, its unusual structural characteristics as evidence that, warrant extraordinary investigation. Loeb's analysis suggests that the mathematical precision required for 3I Atlas's path, which actually provides optimal reconnaissance opportunities while passing close to multiple planets, exceeds what we'd reasonably expect from random cosmic events. His Galileo project at Harvard has been mobilized to conduct systematic observations using multiple telescopes worldwide, specifically searching for signs of artificial construction or technological signatures. However, mainstream astronomers like Sarah Seeger from MIT and Alan Fitzsimmons from Queen's University Belfast urge extreme caution, emphasizing that extraordinary claims require extraordinary evidence and that natural explanations should be exhausted before considering artificial hypotheses. The scientific community now finds itself balancing healthy skepticism with the recognition that, if 3I Atlas does represent extraterrestrial technology, the implications for humanity's understanding of our place in the universe would be, revolutionary, and potentially terrifying in their scope and consequences. Observing the visitor. Astronomers across the globe have mobilized an unprecedented array of telescopes and instruments to study 3I Atlas as it journeys through our solar system, creating the most comprehensive interstellar object observation campaign in history. Major facilities including the Very Large Telescope in Chile, NASA's Hubble Space Telescope, and the revolutionary James Webb Space Telescope are collaborating to collect multi-wavelength data that could, hopefully, unlock the secrets of this cosmic visitor. Michelle Bannister from the University of Canterbury notes that this coordinated effort involves over 50 professional observatories and, honestly, numerous amateur astronomers contributing observations and analysis. The Southern Astrophysical Research Telescope has been conducting detailed spectroscopic analysis to identify specific molecules and compounds in the object's coma and tail. Ground-based facilities like the Gemini Observatory and Keck Observatory in Hawaii are providing continuous monitoring of brightness changes, rotational periods, and thermal emissions that reveal internal heat distribution patterns. Canada, France, Hawaii telescope observations have captured deep images showing faint cometary activity even at great distances from the Sun. This international collaboration represents a new model for rapid response astronomy, with data-sharing protocols that allow real-time analysis and immediate follow-up observations when unusual phenomena are detected, ensuring that no critical information about this rare interstellar visitor is lost. Dawn of a new era. The detection and intensive study of 3I Atlas heralds the dawn of a revolutionary new era in astronomy, where interstellar objects transform from rare curiosities into, critical scientific targets that could reshape our understanding of galactic evolution and cosmic chemistry. Robert Jedica from the University of Hawaii estimates that technological advances, particularly the upcoming full operation of the Vera Rubin Observatory with its revolutionary LSST camera, promise to dramatically increase detection rates, potentially allowing astronomers to study dozens of interstellar visitors annually within the next decade. This technological revolution will create an unprecedented catalog of interstellar objects, providing statistical samples large enough to offer meaningful insights into galactic dynamics, planetary system formation processes, and the distribution of complex organic molecules across different stellar environments throughout our galaxy. Mark Norris from the University of Central Lancashire predicts that this growing database will reveal patterns in interstellar object populations that could answer fundamental questions about stellar evolution, planetary ejection mechanisms, and the chemical evolution of the Milky Way. As astronomers continue to unravel the mysteries of 3I Atlas and prepare for an influx of future interstellar discoveries, humanity stands at the threshold of a new cosmic perspective, one that will fundamentally transform our understanding of our place in the universe and the evolutionary history of our galactic neighborhood, potentially revealing whether we truly are alone or part of a larger community of cosmic civilizations. As 3I Atlas continues its mysterious journey through our solar system, it carries with it questions that could fundamentally alter humanity's understanding of our cosmic neighborhood. Whether this ancient wanderer represents exotic natural phenomena or, something far more extraordinary, the implications are honestly staggering. The coming months will be crucial as this interstellar visitor approaches its closest encounter with our sun, potentially revealing secrets that have traveled billions of years to reach us. Keep following InnoVision Tech for the latest updates on this developing cosmic mystery. Like, share, and subscribe. An object from another star system is blazing through our own, and it's putting on a show that has astronomers scrambling. This isn't just another rock, it's an interstellar messenger that's rewriting the rules as it gets closer to our sun, glowing 6 times brighter than anyone predicted. What is fueling this incredible outburst, and what secrets from a distant star does it carry? Let's explore this together. The numbers don't lie. So what do we actually know about this visitor? Let's break down the hard data. Right now, the interstellar comet designated 3I Atlas is roughly 2 astronomical units from the Sun. That's double the distance between the Earth and our star, about 300 million kilometers. Its speed is almost difficult to comprehend. It's currently traveling at nearly 60 kilometers per second and is still accelerating. By the time it makes its closest approach to the Sun, that velocity will peak near 68 kilometers per second. To put that in perspective, that's more than twice the speed of any planet, and fast enough to travel from the Earth to the Moon in a little over an hour. On the brightness scale, 3I Atlas has reached an apparent magnitude of 12. While that's about 250 times too faint for the naked eye, its brightness has been climbing far more rapidly than any models predicted. Its coma, the cloud of gas and dust surrounding the nucleus, has expanded explosively, now rivaling the diameter of Jupiter. While a typical comet nucleus is only a few kilometers across, this expanding atmosphere is what makes it so visible. The sheer scale of this coma is a key reason why it's appearing so much brighter than expected. The unexpected brightness surge. Why is this object causing such a stir? It all comes down to a sudden, dramatic change. In September, 3I Atlas experienced a massive surge in brightness that defied all expectations. The light curve, which is the chart astronomers use to track an object's brightness over time, shot sharply upwards, veering completely off the predicted path. This wasn't a minor increase. The object is now glowing 6 times brighter than models had forecast, a jump of nearly 2 full magnitudes. This jolt sent a wave of excitement and debate through the astronomy community, with experts like Matthew Knight, a specialist in cometary outbursts, analyzing the data. The core of this mystery lies in its coma, the vast cloud of gas and dust that surrounds its nucleus. As the comet gets closer to the Sun, its ices are vaporizing at an accelerated rate, causing the coma to swell to an enormous size, now spanning several 100,000 kilometers. This giant cloud is reflecting and scattering more sunlight back towards us, making the entire object appear far brighter in our telescopes. The rapid brightening suggests that highly volatile ices like frozen carbon monoxide or carbon dioxide, which vaporize farther from the sun than water ice, are driving the activity. Racing against the sun's glare. For astronomers on Earth, the clock is ticking. By early October, the window to observe 3I Atlas is closing, and fast. Every evening the comet appears lower in the twilight sky, getting progressively closer to the blinding glare of the sun. The angle between the comet and the sun, what astronomers call solar elongation, will shrink below 30 degrees by October 21st. That's the critical threshold where even the world's most powerful ground-based telescopes, like the Very Large Telescope in Chile, can no longer distinguish the comet's faint glow from the overwhelming brightness of the sky. Amateur astronomy networks are in a frenzy, trying to capture the last possible images before the blackout. Professional observatories, bound by strict safety protocols to protect their sensitive equipment, have already begun to scale back their observations. Pointing a multi-million-dollar telescope too close to the sun is a risk few are willing to take, as it can permanently damage the sensitive optics. This data blackout is happening just as the comet is expected to reach its most active and interesting phase, leaving a huge gap in our understanding. Mars, the last outpost. Just as Earth's view is about to be lost, the observational challenge shifts 225 million kilometers away to Mars. For a short but critical window, the red planet becomes the only outpost with a front-row seat. A fleet of robotic orbiters will become our eyes and ears. The European Space Agency's Mars Express can capture high-resolution images and chemical fingerprints of the coma. The ExoMars Trace Gas Orbiter is designed to sniff out faint traces of gases like water and carbon dioxide, giving us clues to its composition. NASA's MAVEN, led by principal investigator Bruce Jakosky, can use its ultraviolet spectrograph to study emissions from the comet's gas and dust, while the Mars Reconnaissance Orbiter could potentially resolve the nucleus itself with its powerful HiRISE camera, which can see features as small as 1 foot across from an altitude of 300 kilometers. On October 3rd, 3I Atlas will pass within 28 million kilometers of Mars, close enough for detailed study, but far enough to avoid any danger to the spacecraft. This encounter is our last, best chance to gather close-range data before the comet disappears from view. The Green Mystery. One of the most captivating features of 3I Atlas is its stunning green glow. What's causing this otherworldly color? Spectral analysis points directly to a molecule called diatomic carbon, or C2. Here's how it works. As the comet gets pummeled by solar radiation, the sunlight breaks apart larger carbon-rich parent molecules on the surface through a process called photodissociation. This process excites the resulting C2 molecules, and as they relax back to a lower energy state, they release photons of light specifically in the green part of the spectrum, primarily in what are known as the swan bands around 510 nanometers. This phenomenon is seen in many comets, but the intensity of the green hue in 3I Atlas is exceptional. The work of Nobel laureate Gerhard Herzberg, who pioneered the study of molecular spectroscopy, provides the foundation for understanding these emissions. This color is a real-time indicator of how rapidly the comet's surface is changing and shedding material as it barrels towards the sun. The impossible anti-tail. As if a green glow wasn't strange enough, some observers have reported something even more bizarre, a faint feature pointing towards the sun. This is a so-called anti-tail, and it appears to defy the laws of physics. We normally expect a comet's tail to be pushed away from the sun by solar wind and radiation pressure, a phenomenon seen in famous comets like Comet Arend-Roland. However, the unique geometry of this encounter combined with the comet's incredible speed creates a different phenomenon. As 3I Atlas ejects larger dust grains, those particles are less affected by solar pressure and tend to remain in the comet's orbital plane. From Earth's perspective, as we cross that plane, some of this dust can appear to project towards the sun, creating a sunward spike. The late Michael A. Hearn, a leading expert in cometary dust, developed models to explain these complex dynamics, showing how electromagnetic forces can sometimes rival gravity's influence on charged dust particles. While reports of the anti-tail are still tentative, its presence would add another layer of intrigue to this already mysterious visitor. Not like the others. To truly understand how unusual 3I Atlas is, we have to compare it to the only other interstellar visitors we've ever seen. The first One Oumuamua, discovered in 2017, was a bizarre cigar-shaped object with a high orbital eccentricity of 1.20 and no visible coma or tail. It was a dry, inert shard tumbling through our solar system. 2 years later, 2I Borisov arrived, and it looked much more like a classic comet, with an even higher eccentricity of 3.3. It had a bright coma, a well-defined dust tail, and a chemical makeup similar to comets from our own Oort cloud. 3I Atlas refuses to fit into either of these boxes. Its coma is not only massive but also intensely green, a sign of strong diatomic carbon emission not seen with such intensity in Borisov. Its dramatic brightness surge, a 6-fold increase above predictions, is unlike anything seen with the other two. According to University of Hawaii astronomer Karen Meach, this diversity shows we have much to learn about the small body populations of other star systems. The Mars Encounter Strategy. The hopes of the entire astronomical community now rest on a handful of spacecraft orbiting Mars. Mission planners have spent weeks preparing for the October 3rd flyby, running simulations and allocating precious observation time. The goal is to get a multifaceted snapshot of the comet that would be impossible from Earth. Scientists want to use the high-resolution cameras like MRO's HiRISE, which has a 0.5-meter primary mirror, to try and spot the nucleus and measure its size and shape. Spectrometers will analyze the light from the coma to map the chemical composition of its gas and dust, telling us what kind of alien ices are vaporizing off its surface. Plasma instruments will study the interaction between the comet's atmosphere and the solar wind. No single spacecraft can do it all, and none have promised continuous coverage, but by combining data transmitted through the Deep Space Network, scientists hope to piece together a comprehensive profile of this interstellar visitor. It's a difficult observation, but the potential payoff is a groundbreaking understanding of a body from another star system. Chemistry in motion. Let's dive deeper into the chemistry that makes 3I Atlas so fascinating. The dominant green glow comes from diatomic carbon C2, but it's not the only molecule at play. Some early spectral readings have hinted at the presence of ionized carbon monoxide and the cyanogen radical, both of which can also contribute to a green or blue glow. Debates have already started in scientific forums about the precise mix of these chemicals, often relying on data from powerful spectrographs like the X-Shooter instrument on the VLT, which can cover wavelengths from the ultraviolet to the near-infrared in a single shot. The comet's incredible speed is a key factor here. It means that solar radiation is stripping away fresh, pristine ices from the nucleus at an astonishing rate. We are not just seeing ancient processed material from the surface. We are likely getting a look at the primordial parent molecules that were frozen inside this object when it formed billions of years ago in a completely different planetary system. This makes 3I Atlas a unique chemical laboratory. The fade begins. What happens after 3I Atlas swings around the sun? Its brief moment of glory will be over and the fade will likely begin. Most models predict a sharp drop in brightness as the comet speeds away from the sun's heat, its vibrant coma shrinking and dispersing back into the void. For anyone hoping to catch a final glimpse, it will be a challenge. A large telescope with at least a 20-centimeter mirror will be the absolute minimum, and even then, it will likely appear as just a faint, fuzzy smudge. This is where citizen science will take over. Amateur astronomers and online networks similar to the American Association of Variable Star Observers will pool their observations, using techniques like image stacking to track the comet's retreat. These platforms provide real-time updates on its position and brightness, creating a light curve that professional astronomers will use to understand its behavior. The story doesn't end when it gets dim. Studying the post-perihelion light curve can reveal crucial details about the comet's structural integrity and whether it survived its fiery passage intact. The journey of 3I Atlas through our solar system, though brief, leaves us with more questions than answers. Each data point gathered from this mysterious visitor helps us understand the diversity of objects that wander the galaxy. What does its unique composition tell us about the planetary system where it was born? How many more of these interstellar travelers are out there waiting to be discovered? As it slips back into the darkness, 3I Atlas reminds us that our solar system is not an island, but part of a vast, interconnected cosmos. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our universe. Thank you for watching InnoVision Tech. A Harvard scientist just warned the world. Our newest interstellar visitor is shedding metallic alloys that shouldn't exist. Real data confirms a cloud of atomized nickel streaming from the object, but with almost zero iron, a combination that defies natural chemistry. Harvard's own Avi Loeb is sounding the alarm, asking if these aren't natural, what are they? Some whisper it could be engineered. So what is really hurtling through our solar system? Let's explore this together. The discovery of 3I Atlas. Did you know we've only ever confirmed 3 visitors from beyond our solar system? The latest one just rewrote the rules. On July 1, 2025, the Atlas survey team in Chile spotted a faint, fast-moving object. They named it 3I Atlas, signifying it as the 3rd confirmed interstellar object. Right away the math showed this was no ordinary comet. Its path wasn't just a long loop, it was hyperbolic, meaning it was moving too fast for the sun's gravity to ever capture it. This was a one-time visitor from deep space. Astronomers scrambled, finding earlier images of it in data stretching back to mid-June. By the time of its official discovery, it was already inside Jupiter's orbit, blazing toward the sun for a gravitational slingshot that will send it hurtling back into the void. Its incredible speed, roughly 130,000 miles per hour relative to the sun, and its unbound orbit confirmed what the numbers suggested. 3. I Atlas was born around another star and has traveled for an unimaginable time to reach us. Let me explain what makes this more than just a rock. It's a messenger from an unknown star system, and the message it carries is in its chemistry. The nickel mystery. Here's where the story takes a sharp turn into the unknown. Almost as soon as telescopes focused on 3I Atlas, they saw something that shouldn't be there. Data from the Very Large Telescope in Chile revealed a strong spectral line for nickel, a cloud of it vaporizing off the object's core. But what was missing is what has scientists stunned. There was virtually no iron. That's not just unusual, it's unheard of. In every comet, asteroid, and meteorite we have ever studied, nickel and iron are cosmic partners. They are forged together in the hearts of dying stars and locked into the same minerals. You don't find one without the other. Yet 3I Atlas is shedding pure nickel vapor, with iron being conspicuously absent. Harvard astrophysicist Avi Loeb, known for his bold theories, was the first to publicly highlight how bizarre this is. He argues that separating nickel from iron on an industrial scale is difficult on Earth. In nature, it's considered next to impossible. This isn't just a small anomaly. The nickel-to-iron ratio in typical solar system objects is well established. On 3I Atlas, that ratio is completely off the charts. It's a chemical fingerprint that matches nothing we have ever seen. Carbon dioxide dominance. Just when the nickel problem had astronomers baffled, the James Webb Space Telescope added another layer of impossibility. When Webb pointed its powerful infrared instruments at 3Y Atlas, it found that the gas surrounding the object was overwhelmingly dominated by carbon dioxide. The measured ratio of carbon dioxide to water was a staggering 8-to-1, the highest ever recorded for any comet, whether from our solar system or beyond. To put this in perspective, most local comets have a composition where water is the main ingredient, with CO2 making up only a small fraction. Here the roles are completely reversed. This wasn't a fluke, the readings remained consistent over multiple observation sessions. Some scientists propose that this strange chemistry could be the result of a billion-year journey through interstellar space, where cosmic rays cooked the object's surface. But others, including Avi Loeb, wonder if this is another clue pointing toward an unnatural origin. The second interstellar comet ever detected, 2I Borisov, was also considered chemically unusual for its high concentration of carbon monoxide, but 3I Atlas's CO2 levels are in a class of their own. The Oumuamua precedent. This isn't the first time an interstellar visitor has broken all the rules. Back in 2017, the first ever confirmed interstellar object, named Oumuamua, left astronomers scratching their heads. It was traveling at high speed, had a bizarre, highly elongated shape, and most mysteriously, it accelerated away from the sun without any visible reason. Comets accelerate due to outgassing, where melting ice acts like a thruster, but Oumuamua had no visible tail or coma. This is where Harvard's Avi Loeb first entered the public debate. He controversially suggested that the best explanation for Oumuamua's non-gravitational acceleration was that it was an artificial object, perhaps an alien solar sail designed to ride the pressure of starlight. While most of the scientific community proposed natural explanations, like outgassing of hydrogen ice, or its composition as a nitrogen iceberg, none of the theories perfectly fit all the observations. Oumuamua left our solar system before we could get a better look, leaving a legacy of unanswered questions. Its appearance primed the scientific community to expect the unexpected. Now, with 3I Atlas, we have a second data point that defies easy explanation. Ancient sky metal. Humanity's fascination with strange metals from space is nothing new. Long before we knew about asteroids or interstellar comets, ancient civilizations recognized that some iron fell from the sky, and they valued it more than gold. Take the famous dagger of King Tutankhamun, discovered in his tomb in 1925. For decades, its origin was a mystery, but modern analysis using X-ray fluorescence revealed its blade contains nearly 11% nickel and a trace of cobalt, a composition that perfectly matches that of iron meteorites. No iron smelted from terrestrial ore in that era had such a high nickel content. This wasn't a one-off. Iron beads found in a 5,000-year-old Egyptian cemetery also showed the high nickel signature of an extraterrestrial origin. The ancient Egyptians even had a name for this material, iron of the sky. These artifacts show us that for millennia, humans have been working with alloys that didn't originate on Earth. They recognize these materials as special, as gifts from the heavens. Now, as we analyze the impossible alloys of 3I Atlas, we're continuing that ancient tradition, questioning the origin of metals that fall from the sky. Kilonova formation theory. So, if the metals on 3I Atlas are natural, how could they have formed? There are a couple of cosmic forges violent enough to potentially create such exotic materials. The first is a kilonova, the cataclysmic explosion that occurs when two neutron stars collide. These events are among the most powerful in the universe, and for a few brief seconds they create conditions perfect for the R process. A rapid-fire sequence of neutron captures that forges elements heavier than iron. In the chaos of a kilonova, the normal rules of element production can be broken. Some theoretical models predict that the debris cloud from such a merger wouldn't be uniform. Instead, it could contain pockets of matter with strange elemental imbalances, regions that are incredibly rich in elements like nickel, but poor in iron. If 3I Atlas condensed from one of these exotic debris patches millions of years ago, it would carry a chemical signature unlike anything from a standard supernova or our own solar system's formation. This theory provides a potential natural explanation, but it relies on an event that is both incredibly rare and violent. Asymmetric supernova theory. There's another, equally extreme possibility, a lopsided supernova. We tend to think of supernova explosions as perfectly spherical blasts, but, well, that's not always the case. Some massive stars die in these chaotic asymmetric explosions, flinging different elements in different directions. Astronomers have actually seen this in action by studying supernova remnants like W49b X-ray observations from NASA's Chandra Observatory show that in W49b, iron is concentrated near the core of the remnant, while other elements were ejected outward in high-speed jets. This proves that nature really does have a mechanism for separating elements during a star's death. If a star's core collapses unevenly, the resulting explosion can be directional, creating plumes that carry specific elements hundreds of light-years away. So, it's plausible that 3I Atlas could be a fragment formed from a jet of nearly pure nickel, blasted away from its parent star while most of the iron stayed trapped near the core. Like the kilonova theory, this is a natural explanation. However, it requires a very specific and honestly, pretty violent type of stellar explosion to create the chemical signature we're seeing. Statistical improbability. Beyond its strange chemistry, there's another red flag that has Avi Loeb and others asking serious questions: the object's trajectory. According to Loeb, the probability of a random interstellar object passing so close to several planets in our solar system, Venus, Mars, and Jupiter, in a single flyby, is astronomically low. His calculations put the odds at about 1 in 20,000, or 0.005%. For an event this rare to happen with only the third interstellar object we've ever detected is, to him, statistically suspect. Furthermore, the object's path is nearly aligned with the plane of our solar system, but it's moving in the opposite direction of the planets. This retrograde orbit allows it to sweep past the inner worlds in a way that looks almost like a survey mission. To add to the suspicion, 3I Atlas reaches its closest point to the Sun on the far side from Earth, making it incredibly difficult for us to observe when it's most active. Critics argue that in a vast universe, rare events are bound to happen. But Loeb counters that when multiple anomalies, the metals, the chemistry, and the trajectory, all point in the same strange direction, the possibility of an artificial origin must be taken seriously. The Golden Record Parallel. In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by a team chaired by Carl Sagan, intended as a message in a bottle cast into the cosmic ocean. The records contain sounds, music, and images portraying the diversity of life and culture on Earth, designed for any intelligent extraterrestrial life that might one day find them. Sagan famously said the act of launching this bottle says something very hopeful about life on this planet. The Golden Record is a time capsule, a physical object carrying information across vast distances and times. Now consider 3I Atlas. It's an object carrying materials with a chemical composition so strange it looks like a deliberate signal. This has led some to draw a parallel. What if 3I Atlas is its own kind of golden record? Instead of a message encoded in grooves on a disk, perhaps the message is written in the very atoms of the object, in the unnatural ratio of its elements. It's a sobering thought. We sent a message out into the void, trusting that matter could carry meaning. What if someone else had the same idea? Atomic messages. If 3I Atlas is a message, how could it be written? The answer might lie in isotopic encoding. Isotopes are versions of an element with different numbers of neutrons. On Earth, scientists can already store information at the molecular level by creating unique isotopic fingerprints. By precisely controlling the ratios of different isotopes in a material, you can create a pattern, a kind of atomic QR code that would never occur in nature. An advanced civilization could theoretically bake a message into a metallic object, making it durable enough to survive a journey of millions of years through interstellar space. Such a message would be immune to the cosmic noise that can degrade radio signals. The information would be in the fine print of the object's chemistry. This is why every scrap of data from 3I Atlas is being scoured for these hidden patterns. Are the isotope ratios what we'd expect from a kilonova, or do they show a level of order that points to intelligent design? We're not just looking for a rock anymore, we're looking for a signal hidden in matter itself, a message that has waited eons to be read. Right now we stand at a crossroads. Is 3I Atlas a product of nature at its most extreme and exotic, formed in the heart of a cosmic catastrophe we can barely imagine? Or are we looking at something else entirely, a piece of technology, a messenger, or a calling card from a civilization beyond our own? The data from the Very Large Telescope and the James Webb Space Telescope has broken our existing models and forced us to confront possibilities once relegated to science fiction. The search for answers is just beginning, and the next discovery could change everything we know about our place in the universe. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching InnoVision Tech. What if NASA found conclusive proof of alien technology, but decided to hide it from the world? 3 weeks ago, a hacker group calling itself Event Horizon claims to have done the impossible, pulling 24 gigabytes of classified mission data from NASA's secure servers. The target? A mission to intercept 3I Atlas, the third interstellar visitor ever detected. The files hint at a cover-up of cosmic proportions. So, what did they find that was so disturbing? Let's explore this together. Event Horizon's cyber attack. So how does a clandestine group get its hands on NASA's crown jewels? According to the leaked security logs, this wasn't a brute force attack, it was surgical. In the early hours of September 2, 2025, Event Horizon executed a coordinated cyber attack that bypassed multiple layers of agency firewalls. They exploited a zero-day vulnerability in an outdated Fortran-based mission planning module, a tiny crack in an otherwise formidable digital fortress. The transfer rate was a blistering 571 megabits per second, far too fast for automated security flags to catch in time. Forensic analysts later pieced together a chilling timeline. The attackers gained initial access at 3:14 a.m. Eastern, escalated their privileges to the highest level by 3:19, and began siphoning data at 3:23. In under 7 minutes, 24 gigabytes of compressed files, including internal chat logs, draft reports, and sensitive telemetry from the 3I Atlas intercept mission, were gone. By 3:30 a.m., the connection vanished, leaving behind nothing but a silent gap in the audit trail. Cybersecurity expert Mikko Hipponen has stated that such an attack would require nation-state-level resources, suggesting Event Horizon is far more sophisticated than a typical hacktivist group. The manifesto and distribution. A successful hack is one thing, but what you do next is everything. Hours after the breach, a manifesto from Event Horizon appeared on encrypted forums accessible only through the Tor network. They claimed full responsibility, framing the attack not as an act of digital vandalism, but as a necessary response to what they termed unlawful cosmic secrecy. Their message was a direct challenge to the global intelligence status quo, echoing the methods of groups like WikiLeaks but with a far more specific target. They warned that the leaked files contained material so sensitive that even senior directors at NASA were allegedly kept out of the loop. Their language was blunt: the world deserves to know what its own scientists have found. But Event Horizon didn't just dump the data online. Instead, they began a calculated campaign, distributing blurred screenshots and heavily redacted memos to select journalists and online channels known for covering classified science. No one received the full archive. It was a strategic drip feed, designed to build pressure and credibility, giving the world just enough of a glimpse to understand the immense gravity of what had been taken. Their final warning was a gauntlet thrown down. The files contain evidence that will force the public to confront a new reality. Authenticating the documents. In the world of leaks, authenticity is paramount. So are these files real? The evidence presented by Event Horizon is compellingly layered. The leaked screenshots are plastered with authentic details: bold, block-lettered confidential stamps, thick redaction blocks, and metadata tags showing UTC timestamps that perfectly match the breach window from NASA's own security audit. We see mission patch artwork in the corners, a stylized comet labeled 3I Atlas Int. Every document carries unique identifiers, routing codes, and internal chat handles you'd expect to see inside a major agency. Technical diagrams and draft tables use Courier font headers and bear NASA's internal digital watermark. We even see screenshots of the classic blue and white NASA email interface with subject lines like Atlas Intercept Immediate Action Required and Telemetry Review Anomaly Detected. One partially blurred memo lists technical trajectory data, while another redacted report is marked with the access level TS-SCI, denoting top secret sensitive compartmented information, a classification that restricts access to a small specific group of cleared individuals. The documents bear digital signature strings ending in -JPL for the Jet Propulsion Laboratory and -GSFC for the Goddard Space Flight Center, indicating a multi-center collaboration. Discovery of 3I Atlas. Before the leak, there was the discovery. On July 1, 2025, the real-life Atlas survey in Hawaii, a NASA-funded planetary defense system officially known as the Asteroid Terrestrial Impact Last Alert System, logged a new object tearing through the solar system at an astonishing 130,000 miles per hour, or about 58 kilometers per second. Astronomers immediately flagged it. This was the third interstellar object ever detected, following the bizarre 1I/Oumuamua in 2017, and the more conventional 2I/Borisov in 2019. But 3I Atlas was different. Early estimates put its size at a staggering 26 kilometers across, roughly the size of the asteroid Vesta, and over 25 times longer than Oumuamua. Its trajectory, calculated by the Minor Planet Center, confirmed it was an interstellar visitor on a one-way ticket through our system, with an orbital eccentricity greater than 6.0. Its path was hyperbolic, meaning it wasn't captured by our sun's gravity, and would not be coming back. According to Dr. Larry Deneau, the principal investigator for the Atlas project, an object of this size and velocity is a once-in-a-century detection event. This wasn't just another icy rock, it was an unprecedented anomaly from deep space. Impossible physics and trajectory. Here's where the story takes a sharp turn from unusual to unbelievable. Like its predecessor, Oumuamua, 3I Atlas was not behaving according to the laws of physics. the leaked mission logs from July 18, 2025 show a sudden, inexplicable sideways acceleration, resulting in a velocity change or delta V of 1.5 meters per second. The object changed course in a way that defied gravitational models. For a normal comet, such a deviation could be explained by outgassing, measured by the non-gravitational acceleration parameter A2. However, just like with Oumuamua, initial observations of 3I Atlas showed no cometary tail, no dust and no gas coma to account for the push. Its A2 parameter was effectively zero, yet it was still maneuvering. Trajectory analysts were stumped. They ran models accounting for solar radiation pressure, gravitational pulls from planets, and every known natural force. Nothing matched the telemetry. Dr. Amy Mainzer, a leading expert on asteroids, has noted that explaining such a deviation without observable outgassing requires exotic physics or an artificial origin. The numbers kept pointing to a single, unsettling conclusion. Some force other than gravity was steering this massive object through our solar system. Surface anomalies. The armor problem. When the first high-resolution images from the Intercept mission were allegedly taken, the mystery of 3I Atlas deepened. The object's surface looked nothing like any known comet or asteroid. Analysts flagged a disturbing pattern: bands of smooth, almost metallic-looking plating, broken by lines that ran too straight and were too evenly spaced to be natural fractures. These weren't the chaotic, jagged fissures seen on Comet 67P by the Rosetta mission. They were seams, crisscrossing the surface in a deliberate grid. One analyst, in a leaked internal chat, dubbed it the radiator problem, referring to a network of raised ridges spaced like the cooling fins on a spacecraft. These ribs cast long, uniform shadows, and their regularity was so pronounced that pattern recognition software reportedly flagged them as artificial. The object's albedo, or reflectivity, was measured at 0.7, closer to polished metal than the asphalt dark surface of most comets, which have an albedo below 0.05. Planetary geologist Dr. Carolyn Porco has emphasized that nature does not produce such perfect, large-scale geometric patterns. This wasn't just an odd rock. The leaked images suggested it might be wearing armor. Thermal signatures and heat pulses. If the surface looked engineered, the thermal data was even more alarming. According to the leaked files, infrared arrays recorded heat vents pulsing with incredible regularity. The logs show heat pooling along the strange ribbed seams, and then bursting outward in tight, directed jets. This wasn't the broad, chaotic outgassing you see in a typical comet. These were discrete, timed pulses occurring precisely every 90 seconds, raising local surface temperatures by over 200 degrees Kelvin in an instant. The mission logs classified this as a directive motion event, a term typically reserved for spacecraft thrusters, not natural phenomena. Even more damning, trajectory analysts correlated these thermal pulses directly with the object's mysterious course corrections. After each 90-second heat burst, the Intercept team logged a subtle but precise shift in its path. The efficiency of this propulsion, measured as specific impulse, was calculated to be far beyond any chemical rocket, consistent with advanced ion or plasma thrusters. Gravity couldn't explain it, solar radiation is constant, and natural outgassing is random. The evidence was building 3I Atlas wasn't just moving strangely, it appeared to be actively propelling itself. Chemical composition mysteries. The story gets even stranger when you look at the chemical makeup. According to a leaked memo from the Goddard Space Flight Center, the first full infrared spectrum analysis of 3I Atlas yielded a bizarre result. The spectra lit up with incredibly sharp lines of nickel. Now, nickel itself isn't entirely unusual in space rocks. It's often found in iron-nickel alloys. But here's the kicker. In the data for 3I Atlas, the signature for iron was almost completely absent. In the entire catalog of known asteroids and comets, a composition of refined nickel without its constant companion, iron, is unheard of. Furthermore, the memo noted the absence of common silicates and carbonaceous compounds. Meteoritics expert Dr. Meenakshi Wadhwa has confirmed that such a separation of nickel from iron requires industrial-scale processing at very high temperatures, a process not known to occur in nature. It suggests a material that has been engineered, not one that formed naturally. The memo was allegedly sealed within hours under a restricted access embargo, but the data was clear. An object with an artificial structure was made of an equally artificial material. radio echoes and communication patterns. Beyond its motion and materials, the most chilling evidence in the leaked files points toward active technology. According to the logs, radio astronomers reviewing raw data from the Intercept mission flagged a pattern of faint, repeating echoes in the X-band frequency range. These weren't natural radio bursts or cosmic static, they were precise, clipped signals with a high signal-to-noise ratio, bouncing back from 3i Atlas at regular intervals. What made this truly shocking was the timing. The interval of the radio echoes mapped almost perfectly to the 90-second rhythm of the object's thermal pulses. It was as if something was pinging the object, and the heat pulses were the response. In one of the leaked chat logs, a veteran telemetry specialist reportedly wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." This completely changed the nature of the investigation. SETI pioneer Dr. Jill Tarter has long argued that a truly intelligent signal would likely be efficient and information-dense, characteristics that align with these alleged repeating echoes. The data suggested it could be an active, responsive probe. Expert analysis and propulsion theory. This is where a very real and very famous scientist enters the picture, Harvard astrophysicist Avi Loeb. While he has not commented on this alleged leak, his previous analysis of Oumuamua via the Galileo project provides a stunning framework. The leaked analysis of 3i Atlas goes even further than Loeb's theories. The directed heat pulses and course corrections are consistent with a sophisticated ion drive or a similar propulsion system. But the alleged smoking gun came from a microscopic fragment recovered by the interceptor's dust collector. Under an electron microscope, technicians reportedly saw a lattice of silicon with doped traces of phosphorus, arranged in layers spaced at micron intervals, identical to the architecture of a semiconductor wafer, with visible PN junctions. A materials scientist would immediately recognize this structure. No known natural process from supernova shock waves to planetary formation can create such ordered, layered microstructures. The memo's summary line, though partially redacted, was legible. Semiconductor structure detected. Artificial origin cannot be excluded. This single finding, if true, moves the conversation from anomaly to artifact. So, what do we make of all this? A 26-kilometer object from another star system, moving at impossible speeds, making its own course corrections. It has a surface that looks like armor, a composition of refined nickel, and it pulses with heat and radio echoes on a perfect 90-second clock. And finally, there's a fragment of what appears to be a microchip. The leaked files, if authentic, present a disturbing and profound reality. The questions are staggering. What is this object's purpose? Where did it come from? And perhaps most importantly, what else has NASA found that we don't know about? Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching InnoVision Tech.